Hi, my name is Jennifer Smith. I'm a math instructional coach for Fort Bend ISD. Get excited because it's time to take a minute for math. In 5th grade, students are expected to be able to add and subtract positive rational numbers with fluency. What does all that fancy math jargon mean? Well, it basically means that students must be able to select an appropriate method to accurately solve addition and subtraction problems involving whole numbers, decimals, or fractions. These fractions could be proper fractions, improper fractions, or even mixed numbers. Today, we are going to focus on subtraction involving mixed numbers. So I'm first going to start with the problem 4 7/8 minus 2 6/8. These are called mixed numbers because they are a mix of a whole number and a fraction together. Since math models are an essential tool for understanding and solving math problems, the first step in solving this problem will be to draw a model. So I've created my math model to represent 4 7/8. So I have 4 holes, or 4 completely shaded in, and then I have 7 out of the 8 parts in my last hole shaded in. What I need to do now is subtract 2 holes and 6/8. So if I take away 1 hole, 2 holes, and I go to my last rectangle and I take away 6/8, I'm left with 1/8 here, and 2 holes here. So 4 7/8 minus 2 6/8 is 2 1/8. If I were to use the standard algorithm to solve this problem, I would first have to line up my fractions, 7/8 and 6/8, and then I would need to make sure my whole numbers were lined up as well. Then I need to refer to my denominators, which tells me how many parts are in each whole. I see that they're the same, which means I can subtract. If they're the same, I keep the same denominator again. I then subtract my numerators, which are the number of parts in each one. 7 minus 6 gives me 1. And I subtract 4 minus 2, which gives me the whole number of 2, giving me the answer of 2 1/8. It's the same number I got when we made our models. So I'm sure you're thinking, wow, it was much faster to use the standard algorithm than making those models. Well, that may be true for this problem, but let's try a different one. All right, so the next problem we're going to solve is 3 2/4 minus 1 3/4. So of course, the first thing I'm going to do in this case is make my math model. I have 3 completely shaded in and 2 parts out of 4 total parts shaded in here. Now I need to take away 1 3/4. So I'm going to get rid of 1 whole. I only have 2/4 here, so I can get rid of these 2. That means I need to get rid of another 4th because I'm subtracting 1 whole and 3/4. And what I have left is 1 whole and 3/4. So the difference between 3 2/4 and 1 3/4 is 1 3/4. So now I'm going to solve this using the standard algorithm again. So we'll line up 2 fourths and 3/4. And then I will line up my whole numbers, 3 and 1. I need to subtract. They have the same denominators or like denominators, so I am able to subtract. So 3 minus 2. Oh no, I can't take 3 from 2. Okay, I'm going to have to borrow from this whole number over here. So if I borrow 1 from this whole number, the 3 becomes a 2. But I can't just stick a 1 over here, because once I cross over to this side, that 1 needs to be able to be added to my fraction. So that 1 has to become 4/4, because anything over itself is equal to 1. So now 2/4 plus 4/4 gives me 6/4. Okay, now I think I can subtract 3 from 6, and that gets me 3/4. And now I can subtract the 2 from the 1, then that gives me 1/4. And so I do again get my answer of 1 and 3/4. This time it wasn't so fast. The key to building understanding is through the use of math models first, so that when you are ready to use the standard algorithm, you know why you're doing what you're doing and not just following steps that you've memorized.